We're going to talk about how we can measure angles, the different methods for doing so, and some of the things based on that. Now, in mathematics, we normally prefer radians as our measure of an angle. However, in a lot of other fields, they prefer degrees. So it's important to be able to go back and forth between both methods. Now, how does a radian work? So the idea is if you draw out a circle and you figure out what your radius is of your circle, and if you were to travel along on the outside of the circle until you get to the exact same distance as your radius, so you want that distance around to be r, well, if you do that, this inside is the definition of what 1 radian is. So again, 1 radian is the angle that is needed, that if you travel around the outside of the circle, you will travel the same distance as the radius of the circle. And so what else can we say about radians? We can also say that there are 2 pi radians in a circle. We can also say that, half a circle then would be pi radians, and so on. And there are reasons that you'll see much later that radians are the choice for mathematics, specifically in calculus. However, at the end of the day, most people are more familiar with degrees, and so a lot of people, they do all their work in degrees, and then they just convert their answer to radians if needed, or vice versa. They just use whatever the system they're most comfortable with. Now for degrees, it is different. For degrees, there is no fancy thing that says you go the same distance outside as you do the radius here. For degrees, they just define that 1 full circle should be the same as 360 degrees. Now 360 is based on 60 here. 60 is a pretty commonly used number in mathematics, and 360 is 6 of those. But regardless, the degrees are just based on 360 degrees is 1 full circle, so that means 1 degree is 1 over 360th of a circle. But the problem is, can you really imagine exactly how much is 1 360th of the way around? I certainly can't. So it's, degrees, even though we're familiar with them growing up, it's not actually that easy to visualize until you've just seen them before. Now, kind of sub-steps with degrees here. If you don't have a whole number of degrees, there are 2 ways to talk about the fractional part. One is decimal degrees, and that's where we have something like, 38.29 degrees. This is pretty convenient because it's easy to type in a calculator. It's also easy to understand, I'm a little bit more than a quarter of a degree more than 38, so we're kind of familiar with how big they are. However, historically, and I believe some with nautically, trying to map how you're moving and so on, a lot of times people will do degree, minutes, seconds. So that'd be something like 26 degrees, 12 minutes, and 20 seconds, something like that. And these are not minutes and seconds of time, these are minutes and seconds of degrees. And think about this, think about how minutes and seconds are fractions of an hour. So 1 minute of time is 1/60th of an hour, and 1 minute of a degree is going to be 1/60th of a degree. And 1 second here of a degree is going to be 1/60th of a minute. So in terms of notation here, 1 minute is 1/60th of a degree, and 1 second is 1/60th of a minute, which is 1 over 3600 of a degree. Now, one of the things we're going to want you to do is to be able to convert back and forth between these different ways of writing them. So this first one says, I have pi over 4 radians. I want to go to degrees. Well, the way that we go from from radians to degrees is we are going to multiply by the following here, 180 degrees over pi. And we use that because we saw up here that pi is half of a circle, and half a circle is also 180, so 180 over pi are the same number. That means the fraction is the same as 1 here. And if you do 180 divided by 4, you should get 45 degrees. And then we want to do the reverse process, going from degrees to radians. We'll take our 120 degrees, and instead of having 180 over pi, we put pi over 180, so the degree parts cancel out. We're left with the pi parts. And let's see, 120 over 80, we're going to get 2 pi over 3 here. So that's how we convert between radians and degrees. If we want to convert things between degree, minutes, seconds, and decimal degrees, we do the following here. We say, okay, we have the 23 as the whole number. That's good. And then 0.75, if I want to convert that to minutes, I multiply by 60 to say how many minutes are we going to have. And the reason we do it that way is because if there are 60 minutes in one whole degree, and I have 0.75 degrees, then how many minutes do I have? I have 0.75 times 60. I'm going to get 45 here. And so that means that 23.75 degrees is the same as 23 degrees, 45 minutes. Okay. Now if I want to go the reverse fashion here, I have 48 degrees, 25 minutes, 30 seconds. Well, I can change the 48 degrees to 48 degrees. 25 minutes is the same as 25 over 60 degrees. And 30 seconds is the same as 30 over 3600 degrees. And if we go ahead and put this in our calculator here, we get the following answer. Now note that I'm going to have to, I'm going to write this 48.425. Now I chose an example here where it kind of works out nicely, but it won't always be true. So just be careful. If you might have to round, then so be it. The next thing, it's just a quick little mention here, is these two formulas. We don't use them all that often, but sometimes they can be pretty important. And that's talking about if you have a circle and you want to find either the arc length, so arc length is going to be this distance around the edge here. We call that S. And it's a very simple formula that if you want to find S, you just multiply the radius times the angle. I do want to point out that for both of these, theta needs to be in radians. If you use degrees for your theta, you are not going to get the right length there. So here's the first time that radians does actually matter in mathematics. There are more in the future. And the second thing that's on here, the second formula, is if you want to find an area of this, it's called sector. You can do that by the simple formula. A is 1/2 r squared theta. Once again, using the theta is in radians. Now the last part on this particular video is going to be talking about something called linear speed and angular speed. So linear speed is something like I'm driving 50 miles an hour, right? It's how far you are traveling distance-wise. And you've probably seen this before. Distance is rate times time, or the velocity or the rate is distance divided by time, right? You say if I travel 120 miles in 2 hours, I can do 120 divided by 2, it's 60 miles an hour on average. On the other hand, angular speed is talking about how much angles you are having over time. So you can talk about how many degrees you are per minute. You can talk about how many radians you are per minute. Sometimes they use a variant of this called revolutions per minute, right, or RPM. If you've driven a car, you might have seen the RPM gauge on your car. That's how fast it's rotating, your engine rotating at any given time. And so for that, instead of taking distance divided by time, we take angle divided by time. But if you use those two formulas, you get the following equation here, that the velocity or the linear speed is the same as the radius times the angular speed. And I know it's unfortunate we use that weird W, it's called omega, the Greek letter. But let me give you an example where we can use this for. It says, suppose you're riding on your bicycle, and you know your bicycle tire has 18-inch diameter, and we know that we are traveling at 3 miles per hour. I know this is kind of small, but I wanted to keep the numbers manageable here. And just to convert it to useful units here, 3 miles per hour is the same as 52.8 inches per second. And it says I want to find the angular speed of your tire's rotation. So what we know here is we know the equation V equals RW. We know that our V is 52.8 inches per second. We know our radius is 9 inches. And again, it's the radius, not the diameter. That's why I had to divide it by 2. And then times omega here. And then if I divide 52.8 by 9, I get the following here. Omega is 5.87. And if you're curious what units we have, you can see the inches are going to cancel out, but you still have the per second. And in particular, it's a unitless expression here. Radians is actually unitless, so this is actually radians per second.